What's up, everyone? In this issue of Platinum Tech, we are conducting the ultimate coil pack test. After releasing our Platinum Tech video on R35 coil pack kits, a lot of people were asking just how the guys from Platinum Racing Products tested all the coil packs and worked out that the R35 was the optimum choice for their kit. Well, you're in luck, because today we're going to show you how. Now, the guys from Platinum Racing Products came up with a coil pack test rig that measures the actual energy output rather than just measuring the current draw, as this is a much better indication of exactly how good the coil pack really is. Now, it measures it at different RPM, different dwell timings, different voltages, and over time and different heat soak to give a much better cross-section of information to truly test the coil pack. Now, here's a fun fact. Out of all the coil pack manufacturers, only one that we tested actually provides you with information about the actual energy output, and the test we did matched up with that perfectly. So we know the test is accurate. Now, each coil pack gets tested between 4 and 8 hours. So all up, there was weeks worth of work that the guys at Platinum Racing Products did. Now, first up, Herman is going to show you exactly how the test rig works. Then we're going to show you which coil packs we tested and the results.
We've spent the last couple of weeks testing all the popular coils on the market, from your LS1s to LQs, your IGNs, your ДENSO, YARIS coils, R35 coils, Hitachi, some SPLITFIREs, OEM coils, the works, to come and present a heap of information that will show you how we lead to the coil of choice, being our coil. We're just going to run through some of the equipment that we use to test coils. We have a laptop, oscilloscope, obviously details come up on the laptop, we can view what's happening there. We have our ECU, which controls dwell and RPM. We have the laptop, obviously, so we can integrate and view what's happening with the ECU, make changes. We have our power supply. We use a 16-volt power supply, which is more than ample for what we need. We have a relay box to run our ignition coil and our other hardware. The actual coil, the lead, and all the details and bits and pieces that we need to take our measurements, set our spark plug gaps, and predict a real-world testing environment. All this is done through the aid of a Zener voltage diode testing clamp, which we put together ourselves. It was fairly tricky. We spent quite a lot of time getting this right, but now we have very accurate measuring capabilities. Okay, so the advantage of this test, it gives us actual coil output as opposed to measuring the current draw of a coil, which is night and day difference. I'll give you a scenario. There could be two coils that draw the same amount of current, but the output could be light years away from each other. So all that information is only really relative to a dwell table. It doesn't tell you which coil's better, how much output it gives off. So the only way to actually test it is with equipment like this, because it's real data, it's actual energy being pushed out by the coil, and everything else is irrelevant as far as we're concerned. Okay, so now I'm going to run you through our testing procedure. It's quite extensive. It takes quite a long time to test different voltages, as you can see here, different dwells, and work out the saturation point of every coil, because the optimum discharge peak performance of a coil is just before saturation. So you've got to go through and work it out, take an average on all the readings to present a qualifying type average per coil. You also might want to back-to-back two original coils, the same coils, to make sure your data is consistent. So I'll run you through how we do that. Dwell timing is really important to test on all coils because it varies so much. You can have two of the exact same coil with slightly different dwell settings. Some coils run a very low dwell, others are extremely high. You can't just go and swap a set of coils and not check the dwell settings. You're not getting the maximum performance out of your coils unless you are pumping the dwell in that is required to get that coil to perform. Next thing we measure is voltage. All alternator systems, all vehicles draw different currents. Every car runs on a slightly different voltage. We needed to get the scope. To give you an example how much voltage affects a coil output, R35 coil drops from 14.5, say, to 12 volts. It'll drop around 10% energy output. If you look at a YARIS coil, you could lose up to 50% of its output, dropping from 14.5 to 12. A real-world example is a high horsepower GDR running down the drag strip. It loses its alternator belt. A R35 coil would more than likely get it to the end of that race. A YARIS coil dropping half its power may cause breakdown, and that could be the difference. The last variable in the test is time and RPM. So we want to hold that coil at near saturation for up to 10 minutes, sometimes over, to work out how hot it's getting, to work out how its millijoule output is affected by heat and how long it takes for it to actually heat up. In a real world environment, there used to be, before dwell tables, scenarios where tuners would get a heat gun over the coil, keep punching the dwell into it until the heat started climbing of that coil. So now we can offer an exact dwell table to advise you, the tuner, exactly how much dwell to put into that coil to get peak performance. It's very important. We also check various RPM points to heat it up more, to load it up more, and to establish that it can actually take the RPM that race engines require these days. It can take up to a day to plot time, RPM, dwell, saturation, and output with heat. So to get an accurate understanding of what a coil can do, it's got to be put through all that sort of rigorous testing. We've done it on all these coils in front of us. It's taken quite a long time to get it, but now we can accurately tell you what coil is better for what application and why.
PRP tested an array of smart coils which have inbuilt igniters rather than coils that rely on external igniters or CDI boxes. This was done over 5 to 8 hours at various voltage and dwell settings, with saturation and heat being monitored during the test to make sure the coils were run at a sustainable output rather than where they overheat and wouldn't last in the real world. 16 coils were tested in this comparison based on what is both popular and available at the time. Most coils range between 15 and 55 millijoules, while some hardcore performance coils can go double that. Let's start at the bottom. The SPLITFIRE SILVIA coil came in last with 15.3. In comparison, an old RB25 coil came in at 15.6. An imitation R35 Coilpack from China came in at 23.1, less than half a genuine R35 coil, low enough to damage the reputation if purchased incorrectly. An imitation YARIS Coilpack came in at 23.7. On another note, one of the imitation YARIS coils actually started smoking on the test rig. But a genuine th-DENSO YARIS Coilpack didn't come in much higher at 25.6. The LQ9 Coilpack promised big things, but came in at 29.3 millijoules. Only good enough for 11th place in this group. The LS1 ACDELCO Coilpack rated a little higher at 30.5. Both of the GM Coilpacks are popular for being cheap and are good enough for most NA applications anyway. 9th place went to the RB26 SPLITFIRE Coilpack, a very popular option for the GTR for many years since the 90s. They pumped out 33.6 millijoules. The BOSCH Toyota YARIS Coilpack did much better than the th-DENSO with 34.0. All the talk of how good the YARIS kit is clearly based off the BOSCH version, not the th-DENSO version. 7th place went to the AUDI R8 coil, a very popular choice for aftermarket modifying. 6th place went to an imitation R35 coil from an Australian supplier which rated at 48.2, proof that some R35 copies work well and some don't. There was 4 coils in equal 2nd place. The R35 Hitachi coil, the R35 Hanshin coil, the NISSAN 370Z coil, and the SPLITFIRE R35 coil pack, all which came in at 54 millijoules. The only difference between them is the stalk length, stampings and price. Interesting that SPLITFIRE tested up exactly the same. As well as the best output of any OEM coil tested, the R35 coils also had the longest spark duration with an average of 2 milliseconds. Detachable stalks enables them to be made to suit other cars, and they also have low current draw and low heat output compared to other coils. Hence, how factory wiring is fine on them and they don't need any heat sinks. This proves they are very efficient. The only con to the R35 coil pack really is that it isn't the cheapest of the bunch, but you get what you pay for, and some imitation coils have given them a bad rep at times. The top coil though was the IGN-1A, which HAWTEC and AEM both sell. This thing is a monster, with the test matching the advertised output of 102.7 millijoules, nearly double the R35. But with that high output comes cost and heat. They have a heat sink for a reason and they need to be kept cool. They're also bulky, so they need leads and they generally won't fit into many valley covers. The wiring also needs to be drastically improved over factory spec with thicker wiring and 3 grounds, one to the block, the head and the ECU for them to fire correctly. So there is increased cost to installations. But that's race car stuff for you. Looking at the rankings, you can see exactly why the R35 coil pack was the perfect choice for platinum racing product coil pack kits.